Okay, so today I want to go ahead and look at section 3.4. 3.4 is where we're going to look at the cosine of the sum of difference and tangent of the sum or difference. Now, to get there, I want to go ahead and prove the sine of a sum or difference. In order to do that, I want to ask you, what is the cosine of a sum? What is the cosine of alpha plus beta, preferably without looking at it?
Well, it's cosine squared. No, cosine alpha plus cosine beta, then cosine alpha cosine beta minus sine alpha sine beta.
There you go.
There you go.
Something like that, at least, right?
Yeah.
Cosine alpha cosine beta minus sine alpha sine beta. That is cosine of alpha plus beta. Good. Here's the thing, though. There is a cofunction identity. The cofunction identity says that the sine of pi over 2 minus u is equal to cosine of u, isn't it?
Yeah.
Well, what about cosine of pi over 2 minus u? What's that equal to?
Sine of u.
Sine of u. So I'm going to use this second one here. Notice that up here, I'm going to use u as alpha plus beta. So u is going to be this entire alpha plus beta. Wait, is that what I want? Yes. Yes, I want u to be sine of alpha. I want u to be alpha plus beta. Now, what that's telling me is that sine of alpha plus beta, if that's what u is, using this second one here, I'm going to replace it with a cosine of pi over 2 minus the entire u, which in this case is the entire alpha plus beta. Good. But notice something, I can go ahead and distribute that negative there. That's going to give me cosine of pi over 2 minus alpha minus beta. And I'm going to do something kind of crazy. And I'm going to group pi over 2 minus alpha together. Think of that as one big angle, pi over 2 minus alpha. I should have done the negative up here. But notice that the cosine of a difference is very similar. It's just that if it's the minus, we'll use the plus. So if you want to write all this together, you can say cosine of plus or minus beta is equal to the cosine alpha cosine beta minus plus sine alpha sine beta. Not plus or minus, because if we're using the top one here, we have to use the top one here. If we're using the bottom one here, we need to use the bottom one here.
So plus minus and minus plus is the same thing?
No. The top side is plus, so the top side is minus. The bottom side is minus, so the bottom side is plus. It's always the opposite. So we're going to use the cosine of a difference formula here. So what's this going to be? Well, it's going to be cosine of the first angle here, and the first angle is that entire pi over 2 minus alpha times cosine of the second angle, and that second angle is beta. Now, this minus sign here tells me that we're going to use the plus, and then it would be sine of the first angle, pi over 2 minus alpha, times the sine of the second angle, beta. Good. But remember your cofunction identities. What is cosine of pi over 2 minus alpha?
Wait, cosine of pi over 2.
What is cosine of pi over 2 minus alpha? It's what?
Sine of u.
Sine of
Alpha.
alpha. So it'd be sine alpha, keep the cosine as cosine beta there, plus, and over here, sine of pi over 2 minus alpha. What's that?
Cosine alpha.
Cosine alpha. And then sine beta just stays as sine beta. Now, what did we start with on the left-hand side this entire time? It was sine of alpha plus beta. So sine of alpha plus beta is equal to sine alpha cosine beta. plus cosine alpha sine beta. Good. Now notice sine is an odd function, right? So sine is odd, cosine is even. What's an odd times an even?
Even.
Odd times an even is odd. Watch, I'll have a 50-50. So that is odd here. And over here, we have an even times an odd. What's an even times an odd? Odd. So we have an odd plus an odd. What does that give us?
Even.
Odd. Think of them as a minus sign. If you have a minus sign plus another minus sign, you're guaranteed going to be minus. Because you're to the left, you go even further left, you're still to the left, right? No, yeah, if you're multiplying them, then it would become even, yes. But adding, subtracting, it has to be all even or odd, all odd. So odd plus an odd is an odd. This all works out. Also, notice that this is a plus here, and that's a plus. With the sign, you use the same. Sign with the same. Yeah, sorry, it's a terrible way of memorizing, but it is a way of memorizing. You're welcome. Okay, so what about the sign of alpha minus beta? Well, sign of alpha minus beta, we could actually go through the cofunction identity to do this, but I'm going to use the trick that we used yesterday in order to prove the cosine of alpha minus beta. Well, sine of alpha minus beta is the same thing as sine of alpha plus the negative beta. Because subtraction really is just addition of a negative. That's all it is. So really, this is equal to the sine of alpha cosine of the negative beta plus cosine alpha sine of the negative beta. Alrighty, so looking through here, notice that sine alpha just stays as sine alpha. However, we have a cosine of negative beta. Now, is cosine even or odd?
Even.
It's even. And with evens, what happens to this negative on the inside?
It goes away.
It goes away. So all we're left with is cosine beta. Good. Now over here, let's deal with the negative beta initially here. That's with sine. Is sine even or odd?
Odd.
So what happens to that negative?
Goes to the outside.
Goes to the outside here, making that
Negative.
minus. So minus cosine alpha sine beta. And that is sine of alpha minus beta. So that is the sign of a difference formula. And again, if you want to, you can combine those into the same thing as sine of alpha plus or minus beta is equal to, actually, let me do this in purple here. So that would give us the sine of alpha plus or minus beta is equal to sine alpha cosine beta plus or minus cosine alpha sine beta. So that's actually both of those combined. Deal. So with sine, you have to have an odd function, which is why we have to have sine and cosine multiplied together. With cosine, it was an even function. That was why we had both cosines and both sines together. Good. Any questions about how I proved that? No, we're all good. Outstanding. So I have just proved the sign of a sum or difference formula. I'm going to go ahead and look at the tangent of a sum or difference formula as well, just to get that out of the way. So we now know the cosine of a sum or difference up here was cosine of alpha plus or minus beta. It's equal to cosine alpha cosine beta minus plus sine alpha sine beta. Down here, sine of alpha plus or minus beta is sine alpha cosine beta plus or minus cosine alpha sine beta. So here's what I'm going to do. I'm going to look at the tangent of alpha plus beta. Well, the tangent in terms of sines and cosines is just sine divided by cosine, right? So tangent of alpha plus beta is equal to sine of alpha plus beta divided by cosine of alpha plus beta. But notice that we have an identity for both of those, for both sine alpha and sine alpha plus beta and cosine alpha plus beta. What was sine alpha plus beta?
Sine alpha cosine beta plus minus cosine alpha sine beta.
Almost. It's sine alpha cosine beta plus cosine alpha sine beta. Yeah, remember with the sine, the starts with an S, same sign. And then all over in the denominator, what is cosine of alpha plus beta?
Then cosine alpha cosine beta minus sine alpha and sine beta.
There you go. Good deal. So it's sine alpha cosine beta plus cosine alpha sine beta, all over cosine alpha cosine beta minus sine alpha sine beta. Fantastic. Now, here's the thing though. We would like to have this in terms of tangent, really, if we can, right? So here's what we're going to do. We're going to go ahead and go through here and we're going to divide everything in here by cosine alpha cosine beta. Okay, so in other words, we're going to have the following. We're going to take that sine alpha cosine beta and we're going to divide it by cosine alpha cosine beta. And then plus that cosine alpha sine beta will be divided by cosine alpha cosine beta. And then all over in the denominator, we'll have the cosine alpha cosine beta divided by cosine alpha cosine beta. And then minus the sine alpha sine beta will be divided by cosine alpha cosine beta. Fantastic. Now notice that in the numerator there, the cosine betas are going to cancel each other in that first one. Actually, let me use green for that. They're easy to read. Yeah, there we go. Cosine betas cancel. In the second one, the cosine alphas cancel. In the third one, both cosine alpha and cosine beta cancel. And in the last one, nothing cancels. So what am I left with? I'm left with sine alpha divided by cosine alpha. What is sine alpha over cosine alpha?
Tangent.
It's what?
Cotangent.
It's what?
Tangent.
There we go.
Oh, it's cosine of sine.
It's tangent alpha there, right? Specifically alpha because that's what their arguments are. And then plus, on the second one, we're left with sine beta over cosine beta. What's that going to give you?
Tangent.
Tangent
Beta.
beta. Good. So the numerator has become tangent alpha plus tangent beta. What about the denominator? Well, notice that everything canceled in that first term there, so it is just 1. And then minus. Now notice that nothing canceled here, but these are different factors. So what is sine alpha divided by cosine alpha?
Tangent.
Tangent alpha. And what is sine beta divided by cosine beta? Tangent beta. And there you go. So tangent of alpha plus beta is equal to tangent alpha plus tangent beta all over 1 minus tangent alpha tangent beta. Now we could go through all of this again and replace the beta with negative beta. But notice if that was negative beta here, oops, if that was negative beta here, that negative goes out here. And if that's negative beta, the negative goes out here because tangent is odd. So if I went through this again, it would then tell me that the tangent of alpha minus beta, would it be equal to tangent alpha minus tangent beta all over 1 plus tangent alpha tangent beta. That is the tangent of a difference. Fantastic. Any questions about that? No questions. Okay. So now we have just proven the sine of a sum and the tangent of a sum were different formulas. And what's nice is that from now on, we could just assume that they're true. That's why we do this. So now we can just do the following. What is the sine of 195 degrees? Well, 195 degrees is not part of our special angles, right? So what are our special angles in degrees? Starting out with the hard one, 0 degrees. There you go. You're welcome. What else are there? 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150 degrees, 180 degrees, and of course keep going from there. But that's the first half of the unit circle, the top half. Now from all this, I want sine of 195 degrees. Now technically I could actually keep going here, and I could say that this is now 210 degrees, 225 degrees, 240 degrees, 270 degrees. That's to the third quadrant. So I could look for what gives me a difference of 195. So I could do maybe 225 and 30 degrees. That would be fine. But that's usually more difficult than adding, right? So let's think of two angles here that can add together to give you 195. Are there any? Any two angles that can add together to give you 195.
135 and 60.
135 and 60. Good. Notice we also have 45 and 150. It doesn't really matter which ones you choose. But that's it as far as I can see for summation at least, right? Again, I could have subtracted 225 and 30. That would have been fine as well. Maybe subtracting 240 and 45. That would have worked as well. So here, I'm just going to use the sine of a sum formula. I'm going to use the 60 and 35 because that's what y'all came up with. So this is the same thing as saying this is the sine of 60 degrees plus 135 degrees. But let's remember the sine of the sum formula. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, right? So sine of 60 degrees plus 135 degrees will be the sine of the first angle, 60 degrees, times cosine of the second angle, 135 degrees. And then plus cosine of the first angle, 60 degrees, times sine of the second angle, 135 degrees. And then we just simplify. What is sine of 60 degrees?
Oh, 1/2. No.
Square root of 3 over 2. Times cosine of 135 degrees.
Square root of 2 over 2.
No.
Negative square root.
Negative square root of 2 over 2. Good. Plus cosine of 60 degrees. 1/2 times sine of 135 degrees.
Square root of 2 over 2.
Square root of 2 over 2. Fantastic. So now that this is all equal to, then just multiply straight across. Square root of 3 times negative square root of 2 gives us negative square root of 6. All over 2 times 2 is 4. Plus 1 times square root of 2 is square root of 2. All over 2. Sorry, 4. My apologies. 2 times 2 is 4. And now we can just add these together. That gives me negative square root of 6 plus the square root of 2 all over 4. Now, of course, you can rewrite it if you want, making that square root of 2 minus square root of 6 all over 4. That would have been fine as well. Fantastic. Any questions about the sine of 195 degrees? By the way, what quadrant is this in? It's the third quadrant. Good. In the third quadrant, is sine positive or negative?
It's negative.
It's negative. And that makes sense here. Because square root of 2 is less than the square root of 6, so a smaller number minus a larger number gives you a negative. Just a small little check here. Now, the sine of 75 degrees. We could add everything together still, right? So let's just do that. What two angles add together to give you 75 degrees?
30 and 45.
30 and 45 degrees. So I want you to figure out what is the sine of 30 degrees plus 45 degrees. Go ahead, see what you got. I dare you. Okay, so overall, y'all are getting this. That's good. So the sine of 30 degrees plus 45 degrees would be the sine of 30 degrees times the cosine of 45 degrees. And then plus the sine of 45 degrees times the cosine of 30 degrees. So the sine of 30 degrees is a half. The cosine of 45 degrees is the square root of 2 over 2. And then plus the sine of 45 degrees, square root of 2 over 2, times the cosine of 30 degrees, which was the square root of 3 over 2. So this is going to give us the square root of 2 over 4 plus the square root of 6 over 4, which simplifies to the square root of 2 plus the square root of 6 all over 4. Outstanding. Any questions about that?
Those correct from the sine way back in the,
What do you mean?
like you flip them, so you know how you have sine 30 degrees
Yes. So if it's sine of 30, cosine of 45, it has to be the other way around. Sine of 45, cosine of 30. Yes. Good. Good. And that's with sine. Yeah. With cosine, it's both cosine and then both sine over here. Yeah. Just the formula. Both cosine and then both sine. Good deal. Number 3, find the exact value of the following. Tangent of pi over 12 and tangent of 75 degrees. Now, this time, I'm not going to write down all of the special angles for degrees. I'm going to write it down for radians. What is the first special angle for radians? Here, I'll help you out. 0. Fantastic. What's the next one? Pi over 6. Then the next one. Good. The next one. Good. The next one. Pi over 2. Good. The next one.
3 pi over 2.
2 pi over 3.
2 pi over 3.
3 pi over 2 is the 270 degrees.
Oh, yeah.
Pi?
No. 3 pi over 4. Then 5 pi over 6. Then pi.
Oh.
So that's the top half of the unit circle in the special radian values. So on the test for this section and pretty much any of the future ones, I am going to include a blank unit circle. The radians will be filled in for you, but you can fill in the units if you want, or the coordinates if you want, but it won't count towards the test. It's just there to help you. Good?
Wait, you said next week there's one that actually does come to the
It does, yes.
Okay.
Yeah, next week's, or I guess this week's, if you want to take it this week, counts towards it, yes. It is one of the questions.
Fill out the whole unit circle.
Fill out the unit circle.
How many points for filling out the unit circle?
5 points. I'm being nice on the unit circle. You're just filling out the coordinates. The radians are filled in. So you're welcome.
So we just going like what, like sin?
No, just 1 0, 1/2 square root of 3 over 2, 1/2 square root of 2 over 2,
Oh,
square root of 2 over 2, 1/2 square root of 3 over 2, 0, 1. Just the coordinates on the edge of the circle. Cosine and sine.
Yeah, yeah.
Okay.
Good. Now, for the tangent of pi over 12, we need 2 values that can give us pi over 12. Now, notice that that's a small number, right? Pi over 12. And so we're probably going to need to use subtraction here. We need a tangent of a difference. Now, what 2 angles here will have a difference of pi over 12 between them?
Power 6.
Pi over 6 and what?
5 5
Well, what's pi over 6 minus 5 pi over 6? Or 5 pi over 6 minus pi over 6? 4 pi over 6 simplifies to 2 pi over 3. That's not quite pi over 12.
Wait, what are we looking for?
We're looking for a difference that gives us pi over 12.
Difference?
Two angles that have a difference of pi over 12.
3. Yeah, pi over 3 and
Pi over 3 and what?
pi over 4.
Pi over 4, yes. Why? Because 1/3 minus 1/4 is 1/12, right? Just use the calculators. Might as well. Now, why choose those? Well, we're looking for the denominator of 12. So more than likely, it would have been pi over 6 and pi over 2. Use the tail here. Pi over 6 and pi over 2. Or maybe pi over 4 and pi over 3, because those have common denominators of 12, right? Or possibly, I don't know, pi over 4 and actually, no, that wouldn't work. Probably just those anyway. That's why I would choose those at least. So it's pi over 3 minus pi over 4. Good. Now then, without looking at your paper, do you remember the tangent of a difference formula? I know you've seen it once. You're like, how on God's green earth do you expect me to memorize this? I was just wondering. It's always a good idea to try and think of it on your own. Okay, go back and look at it real quick.
Isn't it tangent?
There is tangent in there for sure.
Isn't it alpha? Or something like that?
Yep, tangent of alpha minus beta. What's alpha here?
Pi over 3.
Pi over 3, good. Minus the tangent of beta. What's beta?
Pi over 4.
Pi over 4, good. And then all over what?
Cotangent.
No, it's gonna everything's in terms of tangent here.
Isn't it
Oh.
tangent? Pi over 4.
Gotcha.
1. Thank you.
Yeah.
1 plus what?
Pi over 4.
Tangent pi over 3 times the tangent of pi over 4. It's 1 plus tangent alpha tangent beta. Well, good. Do I expect you to know your tangent values?
No.
Yes.
Wait.
What is tangent of pi over 3?
Let's see. So.
Square root of 3. Good. Minus, what's the tangent of pi over 4? 1. Good. All over 1 plus, again, tangent of pi over 3 is square root of 3 times tangent of pi over 4 was 1. Fantastic. Now notice that this is the square root of 3 minus 1 all over 1 plus the square root of 3. But
Where these cancel out?
no, not even a chance. In fact, I want you to take that idea and just literally rip it away from your mind, because you never do that. Why? Why can't you do that?
Because
Because they're terms. Terms don't cancel. If you did that, you could have canceled the ones as well.
oh, it just have to get nothing from 0.
And it doesn't work that way.
That's great.
It doesn't work that way because only entire parentheses cancel where nothing does. Okay. So in the numerator, you can't factor it, right? So there's nothing you can do. But look at the denominator. We don't like having irrational numbers in the denominator, right?
Yeah.
How can I get rid of that irrational number?
Multiply the entire denominator
By
Square root of 3.
1 plus square root of 3.
Square root of 3.
no.
Square root of 3.
Square root of 3.
1 minus the square root of 3. Thank you for not guessing. It's always the conjugate. The conjugate is just keep the numbers the same, but change the sign between the two. So 1 minus the square root of 3 in both the numerator and denominator.
Why do we do that?
Because we want to get rid of that radical in the denominator, that square root in the denominator. Why? Because notice that the denominator now is a difference of 2 squares. It's the product of conjugates, which gives you a difference of 2 squares, right?
Oh, okay.
So we're going to have a minus between the two. And we're simply going to square this. What is 1 squared?
1,
1. And what is the square root of 3
3,
squared?
oh, 3.
3. So the denominator became 1 minus 3.
Isn't that simplified?
It does, but we're not done with it. Look at the numerator now. You have to just distribute those. Square root of 3 times 1. Square root of 3 times negative square root of 3. About negative 3. Because the square root times the square root cancel. So it leaves you with the radicand. You're squaring the square root there, right? Square root of 3 times square root of 3. The square root of 3 squared, which gives you 3. Okay, minus 3. Now distribute the negative 1. Negative 1 times negative 1 is, sorry, negative 1 times positive 1 is negative 1. And then negative 1 times negative square root of 3 is positive square root of 3. Wonderful. Now we need to simplify. Let's look at the numerator here. Negative 3 minus 1. Yes, negative 4. Your brains aren't dead, are they? Negative 3 minus 1. Square root of 3 plus square root of 3. About 2 square root of 3. Good. If it's x plus x, what do you get? 2x. And if x is square root of 3, then you get 2 square root of 3. And then all over 1 minus 3. What is that?
-2.
Negative 2. Wonderful. And at this point, you can just break it up into 2 separate fractions.
The 2's cancel.
Careful. You have to break it up.
And then negatives cancel. -2 and -4.
What is negative 4 divided by negative 2?
Oh, 2.
And then a positive and a negative divide give you a negative. What's 2 divided by 2? 1 leaves us with the square root of 2 there. So our answer is 2 minus the square root of 2.
Actually crazy.
Isn't the
Yes, square root of 3, obviously. I mean, just making sure y'all paying attention. 2 minus the square root of 3. As I said, I never said anything different.
Gotcha.
You believe me, right? Don't answer that.
Sure, I have the recording on like.
I'm gonna go delete it. I can cut that out of it. Yep. Questions? It is fun.
True.
That's crazy talk. Y'all didn't have anywhere near this much fun in 1414.
Oh, this.
Tangent of 75 degrees. Oh, look, that one. We can just easily add 2 things together, right? What are they?
30 and 45.
30 or 45 degrees. So this is asking us, what is the tangent of 30 degrees plus 45 degrees? I want to see if you can do this one on your own. Go ahead. I dare you. Okay, let's go ahead and look at this because y'all are really going about this the hard way. Y'all like doing things the hard way sometimes. That's okay. What is tangent of 30 degrees? Well, sorry, the formula here would be tangent of 30 degrees plus the tangent of 45 degrees all over 1 minus the tangent of 30 degrees times the tangent of 45 degrees. All of y'all got that. What is the tangent of 30 degrees?
Square root 3 over 3.
Square root of 3 over 3. Plus the tangent of 45 degrees was 1. All over 1 minus the tangent of 30 degrees is square root of 3 over 3 times the tangent of 45 degrees was 1. So really, this is just the square root of 3 over 3 plus 1 all over 1 minus the square root of 3 over 3, right? You all pretty much got to this point. Here's the thing, though. There's a lot of complex fractions here. when you have complex fractions, we can get rid of those complex fractions by multiplying by the LCD of all those mini fractions. What is the least common denominator here between the mini fractions? The mini fractions here are here, 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 and here. The only denominator I see between those is what? 3. So I'm going to multiply every term in here by 3. In other words, I'm multiplying both numerator and denominator by 3 here. Distribute that. What does that do for me? Well, that gives me square root of 3 because the 3's cancel each other. Come on, there we go. Plus 3 all over in the denominator, 3 minus square root of 3. See how much easier that's going to be to work with? Because you're no longer working with all those fractions. What y'all were doing was not wrong.
It was harder.
It was just harder. And y'all know me. I'm all about doing things the easy way, right?
Oh, yeah.
Don't answer that. Okay, so 3 minus square root of 3 is the denominator. What's the conjugate of the denominator?
3 plus square root of 3.
Good deal. So we're going to multiply both the numerator and the denominator by 3 plus the square root of 3. So when we multiply all this out, what is that going to give us? Well, square root of 3 distributed, square root of 3 times 3 is 3 square root of 3. Square root of 3 times square root of 3 is just 3. 3 times 3 is 9. And 3 times square root of 3 is 3 square root of 3. Then all over the denominator, that's a product of conjugates, which gives us the difference of squares. Square the 3 gives us 9. Square the square root of 3 gives us 3. And then we simplify. In the numerator, 3 plus 9 is 12. 3 square root of 3 plus 3 square root of 3. What does that give us? We're adding. 6 square root of 3. 3 plus 3 is 6. And keep the radical the same. All over the denominator, 9 minus 3 is 6. Fantastic. So now notice that this just becomes 12 over 6 plus 6 root 3 over 6, which simplifies to 2 plus the square root of 3.
Wait, so I'm on the part where I have a lot of fractions. Can I just
Mhm.
multiply by 3 and get rid of all the fractions?
Absolutely. Or actually, you had those 9s, didn't you?
No, I have square root of 3,
Oh, before you did all that? Okay, yeah. At that point, you can still just multiply by 3.
and it should give me your answer.
Well, once you simplify.
Because I'm not trying to square root of 3, and the 3 plus 1/3 plus 1 plus 3.
Yeah, I wouldn't either. It's not very much fun.
Crazy.
Good deal. Any questions about what I've done here? No? Tends to get fun, doesn't it? Don't answer that. Okay, so use an appropriate identity to simplify these. Notice we have sine 7 degrees, cosine 2 degrees, plus cosine 7 degrees, sine 2 degrees. Well, notice that sine times cosine, that's odd. Cosine times sine, that's odd. So the only possible ones we could use would be an odd identity or an odd trigonometric function. Now, because it's sine and cosine together, we're going to probably want to use sine. Notice that this is the sine of the sum formula. In other words, this is going to simplify to sine of the first angle 7 degrees plus the second angle 2 degrees. And then just ask yourself, what's 7 degrees plus 2 degrees? It's going to give me sine of 9 degrees, and there's just nothing I can do. So that's just going to be sine of 9 degrees. Any questions about that one?
But really, the only tricky part is just finding
Which trigonometric identity it is. Yeah. By the way, on this test, it is probably not a bad idea to do a big brain dump at the very beginning. Know all of your cosine sums of differences, sine sums of differences, tangent sums of differences. And then, of course, we're going to have the double angle and the half angle identities, the product of sum and the sum to product formulas by the time we're done here. In other words, if you look at this back page or this back cover here, we're going to know everything up until, no, I think we'll go everything through the reduction formula. We won't do the oblique triangles. So you might just do a brain dump at the very beginning of the test, go to one of those back pages and just write down all of that. Know it before you go in and just throw it on there just in case you forget it. Not a bad idea.
We have about like 2 weeks to learn all the formulas before we take the test.
Effectively.
Because next week's only.
Next week will be the chapter 2 and the 3132.
Yeah.
Okay, sine of negative t, cosine of 2t, minus cosine of negative t, sine of negative 2t. I don't like having a bunch of different values, but notice that through here, the negative t's, they're both negative t there, right? As long as they're the same argument, I don't really need to change that. But between the 2t and the negative 2t, that's an issue, right? Now I can do one of two things. I can just randomly introduce a negative sign here with the cosine because cosine is even. Or I could take that negative in sine and bring it out here. Which one would you like to do? Use the even for cosine. So this is going to be the sine of negative t, then the cosine of negative 2t. Notice that I can just randomly introduce a negative sign because cosine is even. We love that. Then minus the cosine of negative t, sine of negative 2t. Good deal. So the first arguments in both of the terms are now negative t, and both arguments in the second two terms are negative 2t. Sorry, second two factors there. So notice that sine and cosine, cosine and sine, that is a sine identity. This will be sine of something. I'm going to write down the first argument, which is negative t, and write down the second argument, negative 2t. But notice that this is minus right here, right? Minus means that with sine, you use the same one. So we're going to make that a minus a negative of 2t. What is a negative? What's minus of a negative?
Positive.
Plus, right? So what's negative t plus 2t?
Negative t plus 2t.
Mm-hmm. What is negative t plus 2t?
Positive.
It's what?
T.
There we go. Oh, look, that simplifies to just sine of t. Questions about that? No, no questions. All righty then. Do number 5. I'll give you a full minute for this. Okay, so let's look at this. Notice that it's sine times cosine, then cosine times sine, and the arguments are the same for each of the first ones and second ones. So this is a sine identity. So this would be sine of, now the first argument is alpha. Notice this is plus, so there's going to be a plus there. The second argument is 3 alpha. So it's just alpha plus 3 alpha. And what is alpha plus 3 alpha? 4 alpha. And there we go. Any questions about that?
So if it was cosine, you would change the sign.
If it was cosine, to change the sign. Yeah. Cosine, the way that I remember is there's an O in the middle, opposite. Yeah. Sine S, same.
Yep.
Okay, number 6 is a little bit more interesting. Find the exact value of sine of alpha plus beta if sine alpha equals negative 3/5 and cosine beta equals negative 1/3, with alpha in quadrant 4 and beta in quadrant 3. Now notice we don't want you to solve for alpha or beta. I never want to know what alpha or beta is here. Instead, let's look at what we want to find here. We want to find sine of alpha plus beta, right?
Yeah.
But notice that we're not given alpha or beta, so I can't do just alpha plus beta immediately. So instead, we're going to come over here. We're going to say, what is sine of alpha plus beta? Well, using the formula for sine of alpha plus beta, all that is sine alpha cosine beta plus cosine alpha sine beta, right? That's just the formula for the sine of the sum formula. Let's look at something though. Notice that we know a couple of things. We know that sine alpha is -3/5. So in other words, I know this bit right here. I also know that cosine beta is -1/3. So I also know that bit right there. Here's what I don't know. I don't know cosine alpha or sine beta. And that's what we want to find. But notice we know several different things. We know that sine alpha is -3/5, and we know that alpha is in quadrant 4. In other words, that's just that question where it says, if sine alpha is -3/5, what is cosine alpha, given that alpha is in quadrant 4? We've already done that type of question. You did that in the last test. Or at least you tried to, right? So let's do that now. So sine alpha is -3/5, right? So the fundamental identity of trigonometry is that sine squared alpha plus cosine squared alpha equals 1. And notice that we know what sine alpha is. Sine alpha is -3/5. So I'm going to replace the sine alpha with -3/5. Make sure you do it in parentheses though. And then plus that cosine squared alpha will equal 1. Be careful. When you square anything, it's going to be a positive. One or two of you out there, when you squared the negative, you got negative out of it. So be sure to do that in parentheses if you're using the calculator. Instead, just do this in your head. What's 3 squared?
9.
9. What's 5 squared?
25.
We have 9/25 plus cosine squared alpha is equal to 1. Well, we need to subtract the 9/25, so that means that cosine squared alpha is equal to 1 minus 9/25. What's 25 minus 9? Good, 16. And keep the denominator the same. So this is going to be 16/25. And then use the square root property, of course, which means that cosine alpha is equal to plus or minus the square root of that right-hand side. Now notice that square root of 16 is just 4. Square root of 25 is 5. So cosine alpha is either positive or negative 4/5. To answer which one is it going to be, remember that alpha is in quadrant 4. And we're dealing with cosine here. So in quadrant 4, what is cosine? Positive. It means that cosine alpha will be that positive 4/5 as a result. So now we know cosine alpha right there. That, of course, means we need to find sine beta as a result as well. So again, we're going to do the exact same thing, but this time you do everything in terms of beta. So it means that sine squared beta plus cosine squared beta is equal to 1. What do we know? Well, if we look up here, we know cosine beta was -1/3. So that's going to give me that sine squared beta plus parentheses that -1/3 will be squared, and that will equal 1. Square the 1/3. 1 squared is 1, 3 squared is 9. This means that sine squared beta plus 1/9 is equal to 1. So sine squared beta is equal to, subtract the 1/9 from both sides. What's 9 minus 1? 8. Keep the denominator the same, so it's 8/9. Good. Then we'll use the square root property. So it means that sine beta is equal to plus or minus the square root of 8 over the square root of 9. Now the square root of 8, you could simplify it on your own. It'll become 2 square root of 2. Square root of 9 is 3. And how did I do that? Well, if I take 8 and I do its prime factorization tree, 2 times 4 gives me 8. 2 times 2 gives me 4. Notice that those are all primes. Then I'll look for pairs of primes. There's a pair of 2's there. 2 times 2 is 4. What's not circled is the 2 here. So it's times 2. So really the square root of 8 is the same thing as the square root of 4 times 2, which is asking what's the square root of 4 times the square root of 2, and the square root of 4 is 2. So that's how the square root of 8 became 2 square root of 2. Now, at this point we need to ask, is this going to be positive or negative? Well, if you look up here, beta is in quadrant 3. Now we're looking at sine. Is sine positive or negative in quadrant 3? It's negative. So it means that sine beta is equal to negative 2 root 2 all over 3. Good deal. So now I also know sine beta. Good deal. After I know all that, I can then go figure out what is sine of alpha plus beta. So sine of alpha plus beta is equal to, well, it's sine alpha, and we know that sine alpha was negative 3/5 times cosine beta, and cosine beta was negative 1/3. And then plus cosine alpha was 4/5 times sine beta, and sine beta is negative 2 root 2 all over 3. Good deal. And then you simplify. 2 negatives gives a positive, the 3's cancel, leaving us with 1/5. But because we're going to have a common denominator of 15 anyway, I'm going to make that 3 over 15. Notice we have a positive times a negative, that gives us a negative. Nothing cancels there, so 4 times 2 is 8, and we still have that root 2 on there, so 8 root 2, all over 5 times 3 is 15. Good deal. So notice that we have a common denominator as a result, which means that we have 3 minus 8 root 2 all over 15. Simplify that if you could, but there are no common factors. Now, if you want to, you can break it up as 3 over 15 minus 8 over 15, but there's really no reason to. We already had it the other way around. There are no common factors with all 3 terms. By that one, I mean that one, and that. None of theirs, they don't all 3 share a common factor, right? So that's it. That's as far as you go. So sine of alpha plus beta in this particular situation is 3 minus 8 root 2 all over 15. Good deal. Questions about that? I'm going to leave number 7 as an exercise to the reader, aka you. I'll put the I'll show you the completed ones next time if you want, but try that one on your own. Alrighty. That is all for 3-4. So on Tuesday next week, 3-1, 3-2, 3-3, 3-4 homework are due, and their quizzes. Your unit 2 materials, what I'm going to call it, chapter 2, sections 3-1 and 3-2, that test is due on Wednesday. Notice that on Wednesday, everything closes at noon. So if you're testing on Wednesday, you need to test in the morning pretty early. Okay, so everything closes at noon, which means they'll start taking up tests maybe even around 11:50. So just give yourself plenty of time if you take it on Wednesday. Sound good? Questions?
Sure.
No?
So next week, the homework that's due is 3-1 through 3-4.
Yes. 3-1 through 3-4.
We're only gonna come to class for like Monday and Tuesday.
Yeah, Monday and Tuesday.
That's it.
Yep. Because everything stops at noon on Wednesday. Yep.
Then we're back on regular schedule the Monday after.
Yep. Fun times, fun times.
Every day. Every day, excuse me?